You know that feeling? You buy an electric car, maybe stick some solar panels up, and there's this little glow almost, environmental virtue, like you're doing your part.
Yeah, that feeling of making a difference.
Exactly. Okay, but let's unpack this a bit. Because what if that feeling, well-intentioned as it is just scratching the surface of a much thornier problem?
You mean the fact that we're trying to solve one huge crisis, climate change?
By potentially fueling another one, we're pushing for this carbon-free future, right? But the technologies, the EVs, the wind turbines, they demand this massive, unprecedented surge in resource extraction,
Mm-hmm. A surge in mining, basically.
which could create a whole new set of problems. So this deep dive, we're going to explore those hidden costs, the complexities behind this, seemingly clean transition. We've got some shared material on this race for critical metals.
Right. And it's fascinating because these very technologies, EVs, turbines, even our smartphones, they all rely heavily on a few key metals. We're talking lithium, cobalt, nickel, copper, a whole suite of them.
So our mission today is really to get a handle on the sheer scale of this demand.
Exactly. And the trade-offs involved in actually getting these resources out of the ground and into our gadgets and green tech.
And when we say massive demand, we are not kidding, are we?
No, not at all. The International Energy Agency, the IEA, they put out some startling figures. By 2050, just think about this, they estimate we'll need 15 times more lithium,
15 times.
10 times more nickel, 5 times more cobalt compared to 2022. And that's largely just for the EV market.
Wow. So what's driving this? Is it purely the number of electric cars hitting the road, or is there more to it?
Well, that's a huge part of it, the electrification of transport.
Yeah.
But it's not the only factor. Think about all the renewable energy infrastructure we need to build out.
Wind farms, solar arrays.
Exactly. They need huge amounts of these metals, too. Copper, especially, for all the wiring. And rare earth elements for the magnets and wind turbines.
Plus, we're still buying more phones, more laptops. The whole digital infrastructure keeps growing.
Right. You add it all up, and you get this exponential curve. We saw it in the market between, what was it, 2017 and 2022? Lithium prices went up sevenfold.
Septupled and nickel tripled.
Yep. Copper, cobalt, rare earths, they nearly doubled too. It just shows how critical and potentially scarce these things are becoming.
And the IEA is actually warning about this.
They are. They're warning that supply shortages could genuinely derail the energy transition. We might not be able to mine this stuff fast enough.
So our shiny, high-tech, carbon-free future,
Yeah.
it's completely tangled up with mining, which is, historically a pretty old and dirty business.
That's the paradox, isn't it?
Now, that image of mining, environmentally destructive, maybe socially irresponsible, that reputation was often deserved, historically speaking. But things are changing, aren't they? There's more pressure now.
There is, and it's important to acknowledge that. The way mining operates today is, in many ways, different. You got stricter government rules, evolving standards.
What's the SG and all that?
Right? Environmental, social governance criteria. Plus, there's just more scrutiny from environmental groups, from local communities, indigenous peoples. Companies realize their social license to operate is actually valuable.
Can you give an example, like something that shows this shift?
Well, think about that Rio Tinto incident in Australia back in 2020. They destroyed a really significant Aboriginal heritage site.
I remember that. The backlash was huge.
Exactly, a century ago. The consequences might have been, well, minimal, frankly. But this time, public outcry, intense media coverage, the CEO lost his job, other executives too, they had to make restitutions.
So real accountability. That does feel different.
It suggests a shift, yeah. Companies know they're being watched more closely.
But it's not all giant corporations like Rio Tinto doing the digging, is it? You hear about these junior mining companies. What's their deal?
The juniors, yeah. They play a big role, especially in exploration. Finding new mineral deposits is incredibly risky and needs a lot of capital up front.
So the juniors take the initial gamble.
Pretty much. Think of them like the startups of the mining world. They raise money, do the early prospecting, hoping to strike it rich, or maybe more likely, get bought out by a major company if they find something promising.
High risk, high reward.
Very much so. Most junior explorations don't actually pan out into a producing mine. We are seeing some tech creeping in, though, like cobalt metals, using AI to try and improve the odds of discovery.
Interesting. But okay, despite these changes, stricter rules, new tech, the darker side of mining hasn't just vanished, has it? We're still seeing some really serious problems.
No, Unfortunately, it hasn't vanished, not by a long shot. I mean, just look at the human cost. The fact that at least 320 anti-mining activists have been murdered globally since 2012.
320, that's staggering
Yeah.
and deeply disturbing.
It's a brutal reminder of the dangers people face opposing these projects. And beyond direct violence, the environmental devastation is still a huge concern.
How so? What kind of devastation?
Well, mining and processing ores can release toxic elements. You need harmful chemicals. Sometimes you get radioactive waste. It pollutes air and water. Beyond Obo in China, the big rare earth place, it's kind of a poster child for the environmental mess these processes can create.
And the social impacts, too. We hear about forced evictions, human rights abuses, particularly thinking about cobalt from the DRC.
Absolutely. The Democratic Republic of Congo, its cobalt and copper mines are frequently linked to severe human rights issues, including forced labor and displacement. It's incredibly difficult to reconcile needing these materials for clean tech when their extraction involves such suffering.
And then there's the whole geopolitical angle, relying on countries with questionable human rights records or unstable political situations. That feels risky.
It creates massive vulnerabilities. Think about Myanmar for rare earths or Russia for nickel even after the Ukraine invasion started. Our supply chains are fragile and often ethically compromised.
But let's maybe zoom in on one of these metals. Copper seems absolutely fundamental.
Oh, completely. You hear people calling it the new oil. Some say no decarbonization without copper.
Why is it so critical?
It's down to its properties. It's incredibly ductile, easy to draw into wires, and it's the second best conductor of electricity, after silver, which is way too expensive for widespread use. So it's literally the backbone of electrical grids, essential for motors, wiring in EVs, wind turbines, everything electrical.
And humans have used it for ages, right?
Yeah, one of the first metals we ever worked with, because it was relatively easy to find and shape. Huge role in technological development.
But even somewhere like the US, the history isn't pretty. Montana's Copper Kings. That era sounds quite brutal. Environmental damage exploiting workers?
Oh, absolutely. The history of copper mining in places like Butte, Montana, is filled with environmental destruction and terrible labor conditions. The Berkeley Pit is a massive toxic lake, a legacy of that era.
And that legacy kind of continues in a way. We see copper theft now being a massive problem in places like South Africa.
It's devastating there. Costs the economy billions. Damages crucial infrastructure like railways and power lines. People even die trying to steal it. These illegal miners, the Zamas, risk their lives in dangerous abandoned shafts.
It highlights the desperation, doesn't it? Driven by poverty, but fueled by the high value of the metal itself.
Exactly. It shows how the global demand for these resources creates complex, sometimes tragic, local realities. And today, the big legal copper producers are Chile and the DRC, places also facing huge challenges with environmental damage, land conflicts, and difficult working conditions.
Okay, let's shift to nickel, another key battery ingredient. But the story there, especially in Indonesia, sounds pretty grim too.
It does. Indonesia has pushed hard to become a dominant player in the nickel supply chain for EVs. But it's come at a terrible cost.
What kind of cost?
Reports of multiple worker deaths at Chinese-owned smelters, really poor safety standards, significant environmental pollution from mining waste deforestation.
And ironically, often powered by coal, right, to process nickel for clean energy.
That's the paradox again. Using carbon-intensive energy to produce materials meant to help decarbonize. It highlights the need to look at the entire life cycle, not just the final product.
And meanwhile, the U.S. is barely in the nickel game.
Very limited capacity. Only one operating nickel mine, and that's apparently set to close soon. Almost everything has to be processed overseas. That's a strategic vulnerability for sure.
And cobalt. We touched on it. The DRC, artisanal mines, child labor allegations, awful health impacts.
Yeah, cobalt is perhaps the most ethically fraught of the major battery metals because so much comes from the DRC and involves artisanal mining, which often means dangerous conditions, low pay, and historically child labor. Even the industry-scale mines there have faced accusations of abuses.
Are companies trying to get away from DRC cobalt?
They are. There's a big push to reduce cobalt in batteries or find alternative sources, but the DRC still dominates supply.
Okay, what about lithium, the real poster child for EV batteries? Where does that mostly come from?
The primary source, historically, has been brine extracted from beneath salt flats, especially in South America's lithium triangle, Chile, Argentina, Bolivia. The Atacama Desert in Chile is a major hub.
But that's controversial too, isn't it? The water issue.
Hugely controversial. Extracting lithium brine uses vast amounts of water in extremely arid regions. Local indigenous communities raise serious concerns about the impact on their water supplies, agriculture, and fragile ecosystems like flamingo habitats.
But the mining companies dispute that.
They often argue their water use doesn't significantly impact local freshwater sources, or that changes are due to broader climate patterns. But it's really hard to definitively prove either way, partly because there's often a lack of long-term independent baseline studies before the mining starts. The communities on the ground, though, they report seeing changes.
Sounds like a really difficult conflict. Are there other ways to get lithium emerging? I think I read something about California geothermal.
Yes, there's a lot of interest in extracting lithium from geothermal brines, like those found near the Salton Sea in California. The idea is you're already bringing up hot brine for geothermal power, so you extract the lithium as a co-product. It potentially has a much smaller environmental footprint, especially regarding water use compared to evaporation ponds.
But it's still developing.
Exactly. It's promising, but scaling it up presents technical and economic challenges. There are also projects looking at extracting lithium from certain types of clay or rock, but brine and hard rock mining are still the main methods for now.
Okay, so we're digging up all this new material. But what about all the stuff we've already used? Our old phones, laptops, EV batteries. Surely there's a treasure trove of these critical metals in e-waste. Recycling feels like an obvious part of the solution.
It absolutely should be. E-waste is often called an urban mine. The potential is huge.
But there's always a but.
There usually is. Current recycling rates for things like lithium-ion batteries or the rare earth magnets used in motors are actually quite low.
Why is that? Is it too difficult?
It's complex. Batteries, for example, contain hazardous materials. They can be dangerous to dismantle if not done properly, risk of fires, explosions. The different chemistries and designs also make standardized recycling tricky. And often, it's just not been economically attractive enough compared to mining new materials, though that's starting to change as metal prices rise and regulations tighten.
So where does most e-waste go now?
A lot of it, unfortunately, ends up being shipped, sometimes illegally, to developing countries. You have informal recycling sectors, like in Nigeria, where people dismantle electronics under often hazardous conditions to recover valuable materials like copper. Some materials then flow back to processors in places like China or Europe.
But there are companies trying to do this properly on a larger
Oh,
scale.
yes. Companies like Redwood Materials in the U.S., founded by a former Tesla CTO, and Li-Cycle in North America, are building large facilities specifically for recycling lithium-ion batteries. They aim to recover high percentages of valuable metals like lithium, cobalt, nickel, and copper to feed back into the supply chain.
That sounds promising. But is it enough? Can recycling alone meet the demand?
That's the critical point. Even with much higher recycling rates, which we absolutely need, experts agree it won't be nearly enough to meet the projected demand for these metals in the coming decades, especially with the exponential growth in EVs and renewables. We'll still need significant primary mining.
Right. So if mining is problematic and recycling isn't a silver bullet, what else is there? Making things last longer seems crucial.
You've hit on probably the most impactful, though maybe least glamorous, solution: reducing consumption and extending the lifespan of the products we already have.
That whole embodied energy concept, all the resources and energy that go into making something in the first place.
Exactly. Every time you replace a phone, a laptop, a car, you're demanding a new batch of mined materials. If we could make those things last longer, repair them instead of replacing them, that directly reduces the need for new extraction.
Which brings us to the right to repair movement. What's the goal there?
The basic idea is to push back against manufacturers, making products difficult or impossible to fix. The movement advocates for laws requiring companies to make repair manuals, diagnostic tools, and genuine spare parts available to consumers and independent repair shops at a fair price.
Because often they don't. They want you to buy the new model.
That's often the incentive, yes. Or they restrict access to parts or require specialized software, making independent repair very difficult or impossible. But there's been progress. New York, Minnesota, California, they've recently passed right-to-repair laws covering electronics or appliances.
So that could make a real difference, allowing us to fix our stuff.
It could definitely help extend product lifespans, which, again, reduces the pressure on raw material extraction.
Okay, moving beyond individual gadgets. What about bigger societal shifts? Transportation comes up a lot. Amsterdam was mentioned as an example of reducing car dependence.
Right. Amsterdam's a great case study. They made conscious decisions over decades to prioritize cycling and walking and public transport over private cars.
And the benefits.
Cleaner air, quieter streets, healthier population, less space devoted to roads and parking. And, relevant to our discussion, much lower per capita demand for the resources needed to build and maintain cars.
Because cars are incredibly resource intensive.
Mhm.
Steel, aluminum, plastics, electronics, and now increasingly batteries packed with lithium, cobalt, nickel.
Exactly. And think about the overall cost of car dominance, not just resources, but road deaths, pollution, the huge subsidies often directed towards driving infrastructure and fossil fuels.
It's interesting how places like the US and China actually saw cycling decline massively as car ownership grew.
Yeah, the bicycle was sidelined. But we are seeing a resurgence in many cities now as they build better, safer cycling infrastructure. People are realizing it's often a pleasant, efficient way to get around.
And younger generations seem less car focused, fewer teens rushing to get driver's licenses.
There's some evidence of that trend, yeah. Maybe a sign of shifting priorities. The suggestion then is, what if we shifted subsidies away from fossil fuels and car infrastructure and towards robust public transit and safe, convenient cycling networks?
That could fundamentally change our resource consumption patterns.
It could have a massive impact, potentially reducing the need for millions of individual vehicles and all the metals they contain.
Okay, one last area before we wrap up. This idea of mining the deep sea. It sounds like science fiction almost.
It does a bit, yeah. But it's being seriously explored. The abyssal plains, thousands of meters down, are covered in these things called polymetallic nodules.
Potato-sized rocks.
Basically, yeah.
Mm.
Potato-sized lumps containing nickel, cobalt, copper, manganese, potentially vast quantities of the very metals we need for the energy transition.
Companies are actually trying to hoover these up.
Companies like the Metals Company are developing technology, essentially giant underwater robotic vehicles to collect these nodules from the seafloor. They argue it could be less impactful than land-based mining.
Less impactful how?
They argue no deforestation, no displacing communities, potentially less waste. But the environmental concerns are huge.
What are the worries?
We know very little about deep-sea ecosystems. Scientists warn that mining could annihilate unique life forms on the seafloor that take millennia to recover, if ever. There are concerns about sediment plumes kicked up by the machines, potentially smothering life over vast areas, noise pollution affecting marine mammals, even potential disruption to the ocean's carbon cycle.
That's a massive unknown risk.
A huge unknown. Many scientists and environmental groups are calling for a moratorium on deep-sea mining until we understand the potential consequences much better. There was also another approach, targeting seafloor massive sulfides near hydrothermal vents. But the company leading that, Nautilus Minerals, went bankrupt, facing technical and financial hurdles. So the future of deep-sea mining is very uncertain.
Wow. Okay. So we started with that virtuous feeling of buying an EV.
And we've ended up navigating this incredibly complex web. Resource extraction, environmental damage, serious social costs, geopolitical tensions. It's all tangled together.
It really is. So to recap the key ideas we've kind of wrestled with today.
Well, first, the sheer scale of the demand for critical metals is immense and growing incredibly fast, driven by this clean energy shift and our digital lives.
Right. Second, while the mining industry is changing in some ways, with stricter rules and more scrutiny,
It still faces persistent, serious environmental and social challenges. The problems haven't gone away. We saw that with copper, nickel, cobalt, lithium.
third, recycling. It's got potential, it's crucial, but the current rates are low, the process is complex.
And it definitely won't be enough on its own to meet the booming demand. Not even close for the foreseeable future.
Which leads to the fourth point, the importance of just using less and making things last longer. Extending product lifespans, the right to repair, that seems really vital.
Absolutely. And connected to that, rethinking our broader consumption patterns, especially around transportation.
Yeah.
Shifting away from car dependency could have a huge impact.
And finally, this uncertain frontier of deep-sea mining, a potential new source, but with massive environmental question marks hanging over it.
Exactly. It's a complex picture with no easy answers.
So here's that final thought, something for you, the listener, to really chew on. Given all these complexities, the environmental costs, the human impacts, the geopolitics, and what does clean and sustainable truly mean in this transition? It's not simple, is it? And what difficult choices will we need to make, individually and collectively, to navigate this path responsibly? Maybe think about your own consumption and its hidden ties to these global challenges we've talked about today.